All right, so this video is going to cover writing numbers in scientific notation on pages 1 through 4 of your green packet. So, scientific notation is used often, as it sounds, in science to write large and small numbers. So, if you think about it, science has a lot of really big numbers. For example, the size of the Earth, or the distance from the Earth to the sun, or how big the radius of the galaxy is. Additionally, there's also a lot of really small numbers, like the size of a nucleus, the weight of an atom. So many numbers are either really big or really small. So we want a method of writing a number. So instead of writing 9,300,000 or writing 0.000007, which might be the distance from the Earth to the sun or the radius of the nucleus. We want to write a more compact way of representing it. So every scientific notation number will have this format. It'll first have a coefficient, and this number will always be between 1 and 10. So it'll never be a number bigger than 10 or smaller than 1. It'll also have a multiplication symbol, and then it'll always have a power of 10. So this base will always be 10, and it'll be raised to a whole number that's either positive or negative. So we want to know how to go from scientific notation to standard form. So to do that, we're going to move the decimal of the coefficient as many times as the exponent tells us to. A positive exponent tells us that it's a large number. A negative exponent tells us it's a really small number. So for instance, 9,300,000 would have a positive exponent, and 0.00007 would have a negative exponent. And then we'll fill in the space with any zeros, any empty spaces with zeros. So for instance, positive exponent tells us that this is going to be a large number. So I'm going to write the coefficient 4.56, and then the exponent for this problem is 5. So that's going to tell me to move my decimal 5 places. 1, 2, 3, 4, 5. And I'm going to fill in any empty spaces with zeros. So 4.56 times 10 to the 5th is 456,000. I knew to move it this way to the right because it was a large number. So I moved the decimal to the right to make it a bigger number. Versus here, this has a negative exponent, so it's going to be a small decimal number. So I'm going to move my decimal to the left to make it a smaller number. So I'm going to write my coefficient 3, and my exponent is -4. So I'm going to move the decimal 1, 2, 3, 4 places to the left to make it a smaller number. So my decimal lands here, and I'm going to fill in the empty places with zeros. So 3 times 10 to the -4th is 3 10,000ths. So it's a very, very small decimal. This next one's going to be a large number because the exponent is positive. So I'm going to take my coefficient, 6.847, and I'm going to move the decimal to the right 1, 2 places. So this is equal to 684, and the decimal landed right here, 684.7, which kind of makes sense because think about it this way. 10 to the second, we actually know what 10 squared is. 10 squared is 100. So all I'm really doing is multiplying 6.847 by 100. So it would make sense that I would get 684.7 as my answer. Same thing up here. I was multiplying 4.5 to the 4.56 times 10 to the fifth, which is 100,000. So it made sense why I would get something in the 100,000s. On the other hand, this next one is a negative exponent. So I'm going to be moving the decimal to the left. So 1.2, I'm going to move the decimal 1, 2, 3 units to the left to make it a small number. Fill in my empty places with zeros. So this is 0.0012. So if I want to go from standard form to scientific notation, I'm going to move the decimal point until I get a number between 1 and 10. I'm going to drop any outside zeros. And if I moved my decimal for a large number, I'm going to have a positive exponent. And if I moved my decimal for a small number, I'm going to use a negative exponent. So here, this is a large number. I'm going to have a positive exponent. So I need to move my decimal, which starts right here. 1, 2, 3, 4, 5, 6 times so that I get a number between 1 and 10. 2.4 is between 1 and 10. And I moved it 6 times, and it's a large number, so it's positive. This next one's a small number, so it's going to have a negative exponent. Let's move my decimal until I get a number between 1 and 10. 1, 2, 3, 4, 5. I had to move it 5 times to get a number between 1 and 10. And because it's a small decimal, it's negative 5. So let's try this one. How many times do I have to move this number until I can get a coefficient between 1 and 10? Well, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 movements until I got to 3.456. So I moved that a total of 10 times, and because it's a very large number, it's a positive 10. Versus this next one is a negative exponent because it's a very small number. I move the decimal 1, 2, 3 times to get a number between 1 and 10. So it's 2.3 times 10 to the negative third. So which of these are in correct scientific notation? This first one's not because the coefficient is bigger than 10. 15 cannot be a coefficient. So this one's not in scientific notation. This next one has a coefficient between 1 and 10 and a power of 10. So that's good. This one has a power of 20 at the end. Scientific notation always has powers of 10. This one has a coefficient smaller than 1, so it's not in scientific notation. But these last two are good because they have coefficients between 1 and 10, and they have powers of 10. All right, so let's try these last couple. So I know it's going to have a positive exponent. We got to count how many times we have to move the decimal, which always starts at the end of a really large number. How many times do we have to move it to get a number between 1 and 10? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move it 9 times to get 2.563 as our decimal, 10 to the ninth power. So this next one is going to be a negative exponent because it's a very small number. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times to get 7.8 times 10 to the negative 11th. Another negative exponent here. 1, 2, 3, 4, 5. 5 times to get a coefficient of 3.2 times 10 to the negative fifth. And then lastly, a positive exponent, 1, 2, 3, 4 times to get 1.45 times 10 to the fourth. And so here, because it's a negative exponent, I'll write out my coefficient. And I know I'm going to move my decimal to the left to make it a small decimal. 1, 2, 3, 4, 5, 6, 7, 8 times. So it's 0.0000000015. That's our final answer in standard form. This one I'm going to move to the right to make it a large number. So I start with my coefficient and I move the decimal 1, 2, 3 times. So it ends up being 2,347. This one I'm going to move to the right as well. So I take 5.8 and move it 1, 2, 3, 4, 5, 6, 7 times, filling in all those empty spaces with a 0. So if I write that, it would be 58 million. And then this last one is negative. So I'm going to move the decimal to the left to make it a small number. So I take my coefficient 6 and move the decimal 1, 2, 3, 4, 5, 6 times. And fill in all the empty spaces with a 0. And that's how we do scientific notation.